welcome you to the Dallas Independent School District STEM Environmental Education Center virtual field trip. Teachers, if you're watching, if you're not signed up, please do so. Go to www.tiny.cc/high-school-restoration and sign up for us, please. We would appreciate it. The program this morning will be energy and resources. During this virtual field trip, students will evaluate how the use of energy, water, mineral, and rock resources affects Earth subsystems. They will also differentiate between renewable and non-renewable resources based upon rate of formation and use. Ms. Ram will discuss water resources. Ms. Ramirez will tell you about mineral and rock resources. Mr. Dominguez will talk about renewable resources. Students, during this program, you cannot ask us a verbal question, but you can go to www.tiny.cc/question-answer and send us a question. We'll do our best to answer them during the program. And if not, I'll send the answers to your teacher and they can discuss them with you. Now I'm going to stop sharing my screen, and Ms. Schramm is going to tell you about water resources.
Here we are. So we're focusing on two things today. We're going to be evaluating how water affects the Earth's subsystems, and we're going to be discriminating between renewable and non-renewable resources when it comes to water. So here we go. So today's focus is, by the end of this presentation, I want you to be able to give at least 2 examples of water resources and explain their use and their importance, and also be able to explain why water resources are renewable or non-renewable. Okay, so let's begin. So ways we use water as a resource. Some of these are obvious, and then some you may not experience quite as often. So things that you experience daily, obviously we have drinking water, plumbing, we use it in our toilets, in our sinks, in basically everything, right? There's water all over the place, drinking fountains, everything. Recreation, of course, we use it in our hot Texas summers to fill our swimming pools and water parks and all that. And then in agriculture, to water our plants, water our gardens, water our lawns, water crops, provide water for animals. We use a lot of water out here. That's why we have a lot of water collection units, so that we can water our animals without wasting water from the tap, right? So we like to use rainwater harvesting as often as we can. So some other ways that we use water that you might not see every day, but probably affect you indirectly, are hydroelectricity plants, using water in manufacturing and in industry. So when factories, they use a lot of water to help us create all those products that we use every day. And also harvesting tidal energy. So I'm going to probably focus on the ones on the right, because those are a little less obvious, or a little less common to you. So we're going to focus on that. And first, before we get to that, I want to talk about, is water a renewable resource? So it is, but with a little caveat. So of course, you all know the water cycle naturally recycles water. When the water evaporates, the water molecules are separated from pollutants and other impurities. And then when the water falls back to Earth as precipitation, we can use it once again. But of course, with pollution and overuse, it can damage and destroy local water supplies. So yes, water is renewable, but that doesn't mean that we don't have to be careful with how we use water, how much water we use, and everything like that. So let's continue. So first, we're going to talk about hydropower. I mentioned hydroelectricity and how it may affect you indirectly. So if you've ever seen a dam, I'm going to show you a picture of a famous dam, the Hoover Dam, in a minute. But basically how a dam works is it is at a it's at a river. Okay, so a naturally flowing body of water. And it needs to have a higher elevation moving to a lower elevation, because as the water flows from high to low, due to gravity, the hydropower plant is going to harvest that energy into electricity. So there's not every river can have a hydro plant on it or a dam because, like I said, it needs to have higher elevation to lower elevation. So they're kind of expensive to build, but we've been using dams and hydropower for over 100 years. So hydropower plants use turbines and generators to convert this motion into electricity. So like I said, that motion from high to low due to the gravity is helped to transfer into electricity. Okay. So you can see on the inside, this is kind of how it works. So the water is up here, there's the dam, and it restricts the flow of water. That's basically all it does, is controls how much water can go through at a time. Then it flows down, the water pushes those turbines around and around, goes through the generator, then the transformer, and then distributed off into people's homes and businesses. So here, like I said, is a picture of the Hoover Dam. This is one of the largest dams, and you can see it's pretty awesome. It's kind of spooky actually, but but yes, so the Hoover Dam is a very, very, very famous dam. All right, so let's keep going. So tidal energy. This is another way to get electricity from the motion of water. So tidal energy is a form of power produced by natural rise and fall of tides caused by gravitational interaction between Earth, the sun, and the moon. So I actually just did a field trip recently about the tides and the moon. So basically we get a high tide and a low tide, if you're by the beach, twice a day. So the way these work is kind of similar to if you've ever seen those wind turbines. If you're traveling through the country, you see those giant wind turbines and the wind pushes those blades around and around and around and around. And of course, there's going to be a generator inside that turns that spinning motion into electricity. Well, the tidal energy works a similar way, but instead of moving air, like in the wind turbine, we have moving water. So if you have a high tide where the water comes up, and then a low tide where the water goes down, and that happens twice a day, that's going to be able to create a lot of motion and a lot of tidal energy. So I think those are pretty cool. I tried to find like pictures of what they actually look like. So this is one like being installed, but then of course they're underwater. So when I look it up, mostly I just find a lot of like diagrams that are drawn, but it looks pretty cool. And you can see what it looks like out of the water. It's kind of, yeah, it reminds me of those windmills, but they're shaped kind of differently, of course, because we're dealing with water this time. Okay. All right. So I wanted to talk about ways to conserve water and reduce pollution because, like I said, yes, it is a renewable resources, but with a caveat that we have to take care of it. So ways to conserve water. So that means using less. So you've probably heard these before, but it never hurts to have a reminder. So taking shorter showers, installing a water-saving toilet flush system. So that means, you know, those fancy toilets where they have a button for number ones and number twos. That helps reduce the amount of water you use. And turning off the tap between brushing your teeth and washing your hands, especially now we're washing our hands like every 5 seconds. So if you are turning off the tap between that, that is good. Don't keep the tap running also when you're washing clothes or utensils. So if you're taking a step away to do something else while you're doing your chores, turn that water off and try to make sure you're only actively using it while it's turned on. And then closing taps properly and fixing leaking taps, pipes, and toilets. I remember one time when I first bought my house, one of the toilets just kept running and running and running and running, and my water bill was humongous. And that was kind of my karma for not getting it fixed fast enough. So also ways to reduce water pollution. So not only can conserving or using less water help our natural water sources, we can also help reduce water pollution. So this is a big problem because, you know, our oceans are filling up with plastic and our trash and kind of affecting not only the quality of the water, but also the quality of life for the animals in those environments. And this happens in freshwater, saltwater, basically anywhere there's water, we're making a mess. So pick up your litter and throw it away into a garbage can so that it can be disposed of in a correct place. Don't put fertilizer. This is like more when you're grown up. But don't put fertilizer on the grass right before it rains, because guess what? When you put fertilizer on the grass right before it rains, all that fertilizer and all those chemicals are not going to help your grass grow green and strong and beautiful and healthy. They're going to wash right out and probably go down the storm drain and make the water toxic. So, and then washing your car or outdoor equipment where it can flow into gravel or grassy area instead of the street. So this kind of ties into the last one and the next one, is avoiding putting chemicals or extra stuff into storm drains. So my next way to reduce the pollution is don't pour liquids down the storm drain. So same thing if you're washing your car and using soaps and special stuff on it, or if you have anything else, don't pour it down the storm drain or into the street, because that goes back into our water supply. So that's pretty gross. And then also I added reduce the amount of single-use plastic you use, because we know all that plastic, like I mentioned earlier, is kind of stacking up and polluting our water systems, especially like in the ocean. So try to reduce the amount of single-use plastic. All right, that's all I have for you today. I hope you have a great rest of your day, and I can't wait to see you next time.
Thank you, Ms. Ram. We did have a question. Where does the city of Water get its drinking water from? Now, you know, there's a lot of people in Dallas, so it requires a lot of water. So now listen to this. Dallas currently obtains water from area reservoirs like Lake Ray Hubbard, Lake Louisville, Lake Grapevine, Lake Ray Roberts, and Lake Tawakoni. Dallas also has plans to use Lake Fork and Lake Palestine in the future when the water demands increase. So they're going to tie into 2 more big lakes. So they can furnish the water for all the people that's coming here from other states.
My name is Ms. Ramirez, and in this segment, we'll be talking about rock and mineral resources. Before I get started, I do have an animal friend to show you, and she's going to help us learn about how I use mineral and rock resources. And so she's actually a chicken, and I regret that I don't have the actual bag here, but my chicken actually eats what's called poultry grit. And it's an example of a rock and mineral resource. Poultry grit is just crushed granite. So think of like crushed pebble or rock. And this stuff is super important to a lot of our birds and poultry because chickens don't have teeth. So instead they have what's called a gizzard. It's like an internal sac or an organ. And when they eat their food goes inside that gizzard. They will also eat small pebbles and small little rock and gravel. All of that will mix inside the gizzard, and it will help to crush their food so that they can digest it. So I'm gonna show you guys my chicken friend. This is Pepper. She's a blue silky chicken, and they get that name because they have a blue patch of skin around their ear. And if you guys were to touch her, she is super soft like silk. So she actually depends on earth resources like rocks and minerals. So I'm gonna go ahead and put her up. It is interesting to see her when she's eating those crushed rock and pebbles. Again, it just helps with their digestion. So I'm going to go ahead and share my screen, and we'll start with our presentation. I do have a couple of questions I would like for you guys to keep in mind as we go through the presentation. The first is, at the end of this presentation, you should be able to give at least 2 examples of mineral and rock resources and explain their importance. And then 2, think about our mineral and rock resources renewable or non-renewable, and then explain. So just some background. Remember, rocks are made out of smaller things called minerals, and minerals are made out of even smaller things called elements. And if you remember back from 8th grade, think of your elements in the periodic table. So we're going to be discussing the uses of rocks, minerals, and elements today. All of these are things that we can mine from Earth's crust. So on our next slide, my first question for you guys is to think about, are rocks and minerals renewable or non-renewable natural resources, and why? So given the background information that you guys know about some of these things, what do you think they are? Again, feel free to pause the video to allow for discussion, but I'm going to go ahead and just jump right into it. So of course we know that rocks and minerals take millions of years to form, and they are an example of a non-renewable resource. That is because they can't be replaced quickly after they are used. Now, we learned earlier that rocks and mineral resources exist in fixed amounts on Earth and in Earth's crust. And again, we use rocks, minerals, metals, and other needed elements for a variety of different things. And these things are removed by quarrying or mining. So my second question for you guys is, think about what items do you have that use or contain rocks and minerals in them? And what examples can you find right now in your purse, on your desk, in your classroom, or your room? And I'll give you just a quick second to just look at what you have at your desk or in your purse, or what you can eyeball in your classroom. What are some things that you see that contain rocks and minerals? And it's not as hard as you think. There's actually quite a few. Again, teachers, feel free to pause the video to allow time for students to make their predictions about what they have in their classroom or on their desk. But I'm gonna go ahead and go right into it. Some of the most common things, ladies, you guys probably have a lipstick. Lipstick is made out of different micas. Pencils, I'm sure you guys all have a pencil on your desk right now. That pencil is made from graphite. And I know for sure a lot of you guys have a cell phone. Those cell phones have rare earth elements in them like scandium. And if you're watching us right now, I'm pretty sure you're either watching us on a computer screen, a tablet screen, or maybe even a TV screen. Those TV screens all have lead in them, which is an element that's mined. If you have batteries or something that uses batteries, those have lithium in them. And if any of you guys are wearing jewelry like gold or silver, or if you guys have glasses like I do, they might be made out of nickel. So jewelry and a lot of things you guys probably are wearing right now might be made from rocks or mineral resources. So I'm going to take you guys to this quick little website. It's a cool little poster from the United States Geological Society, but it shows a great example of some common household uses for mineral and rock resources. So on your free time, you guys can look this up. It's from the United States Geological Society, and it's called Mineral Resources Out of the Ground and Into Our Daily Lives. So just taking a quick little look at this, you guys probably brushed your teeth this morning. I hope that has the mineral fluorite in it. We talked about silver and jewelry and in wiring. Halite, if you ate salt or food with salt in it, halite is a mineral. We also have things like copper that's in a lot of our plumbing and our coins. If you guys have money in your pockets or in your purse, those coins that you guys have elements, are made from the elements. We talked about your pencil earlier with the graphite. So again, on your free time, feel free to look at this cool little poster and look at the various other things that are made from rock and mineral resources. So I'm going to take us back to our presentation. And my next thing for you is a little discussion on these rare earth minerals. So these rare earth minerals get their name because they are extremely difficult and costly to extract from the earth, simply because they're not really found very often in their pure form. So they're often usually found within other minerals, so it really makes them hard to extract, and it's super costly to mine them. So that's why they're called rare earth minerals. So some of the common rare earth minerals, there's about 17 of them. The common ones are used for your smartphones, for wind turbines, all those fluorescent light bulbs, the hybrid vehicles, and fiber optics. And here's another infographic for some of those usage. We can see things like catalytic converters in our vehicles, wastewater treatment, all those display screens on our TVs and laptops, satellite electronics, optical glasses, airplanes, hybrid vehicles. So we really use a lot of these minerals pretty much in our everyday life. And then here's our next little infographic. Take a moment to kind of read through this information and see what is it trying to tell us. So this first one on the left, it says, where in the world are all of the rare earth minerals? So again, something interesting about this, if we look at our diagram, we see that China has the largest portion of rare earth mineral reserves, probably followed by Vietnam. Here we have US, which has a very small portion of the pie diagram here. On this side, we have this chart, and this is showing us the mine production. So notice who are the two main producers of rare earth elements according to this chart. And hopefully you guys said China, which makes sense considering they have the largest amount of reserves. But interesting enough, the US is the second largest producer of rare earth elements, even though if we look over here, we have some of the lowest reserves. So we are actually, the US is actually mining quite a bit of what it has in its reserves. And so again, China and the United States are mining the most of those rare earth minerals. And this is important because according to Britannica Encyclopedia, at the current rate that the rare earth element, that we're using those rare earth elements, the world would probably not run out of them for more than 900 years, which I know seems super far away, but think of all the people that are going to outlive us. However, if the demand for these minerals stays at the 2017 levels, we know that historically the demand has risen. If the demand continues to rise, we're going to not have these rare earth elements for future generations. So that's why it's important for us to conserve our natural resources. Because remember, these resources are non-renewable. And then really quickly, here are just some of the effects of extracting and processing these non-renewable mineral and energy resources. So mining removes large amounts of soil and natural habitat. Other forms of mining require people to dig these super big tunnels, which can disrupt the habitat and the local environment. Mining is also a super dangerous job. It can pollute the air and water surrounding the communities. And then also there's competition for rare minerals that can lead to disputes among other nations or countries. So here you can see some of those devastating effects of mining and processing those minerals and also even using them. And then just really quickly, some local rock and mineral resources that we have around here. We're located in Seagoville, Texas, and there's actually, there's a gravel quarry and also a sand pit located near us. So those are rock and mineral resources. Those are often used to create concrete. And then something interesting about the history of Dallas is it was once called the Cement City. And that was in West Dallas, and it has a very interesting history about it. I highly encourage you guys to do some research about it. But in the early 1900s, the Southwest States Cement Company came to Dallas, and they built pretty much their own little community for their workers. Granted, that was way back when in 1909, but Dallas apparently has a huge history with cement, which is a natural resource. And here you can see some pictures here. The last one are some other issues around Dallas. There's Shingle Mountain, which was in Dallas, South Dallas for the longest time. Of course, it was mostly shingles, which are composed of asphalt. And then also in West Dallas, there was a lead smelter factory that eventually had to be shut down because it led to a lot of lead contamination. So there was a lot of children that had lead poisoning because of this lead factory. And lead is another earth material that we also, it's very useful, but if we don't watch the way that we use or process it, it can have some devastating effects. So my challenge for you guys is to research what rock and mineral resources are near you and what are they used for. Also think about some of the positive and negative impacts of their processing and use as well. So that's all I have time for. We're going to give it back to Dr. Gorman to answer any questions.
Hey guys, I'm out here at our beautiful Environmental Science Center, and I am currently outside in a very sunny day. And today we are going to be talking about energy sources, both natural and alternative energy sources. So as you can see, we can't escape the grasp of energy need, but I'm going to discuss some of the ways that we can better our energy consumption and find sources of energy like the sun that are natural and very abundant to meet our energy needs. So I hope you guys learn a little something about what energy sources we use on an everyday basis, and maybe help out our environment and become better consumers of energy. All right, guys, let's review what renewable and non-renewable resources are, because we do need to understand where most of our energy comes from and why we need to shift our thinking into other sources of energy that are more sustainable. So renewable resources, unfortunately, are not where most of our energy comes from. Renewable resources are an energy source that cannot be depleted and are able to supply a continuous source of clean energy. So biomass energy such as ethanol, hydropower, geothermal power, wind energy, and solar energy are examples of renewable resources. However, that is not where most of our energy comes from. So our energy comes from non-renewable resources, or most of it does. So non-renewable energy resources include coal, natural gas, oil, and nuclear energy. So once these resources are used up, they cannot be replaced, which is a major problem for humanity, as we are currently dependent on them to supply most of our energy needs. And it's also worth mentioning that these non-renewable resources are not clean energy. These sources of energy create a lot of pollution. So the conversation on energy should be focused on two things, in my opinion, and that's the problem of pollution and the fact that we are eventually going to run out of non-renewable resources. All right, guys, we're going to start off with a demonstration, and we are going to simulate what greenhouse gases do to our global temperature. For those of you that don't know, greenhouse gases are the gases that are a byproduct of burning fossil fuels, those natural non-renewable resources that we were just talking about. And we're going to do so by setting up two systems. So we're going to have two containers. Each container is going to have water, the same amount of water, and an ice cube. However, one of the systems is going to have the presence of a greenhouse gas, or we're going to simulate the presence of greenhouse gases by adding some carbon dioxide into one of the systems, simply by adding an antacid tablet. Those create carbon dioxide when dropped into water, and we're going to see which ice cube melts first. The one the system that has its ice cube melt first is obviously going to be the one that trapped in more heat. So let's get started. You guys can try this at home. It's a very simple experiment. You just need some containers. If you don't have a top, you can saran wrap the top. You're going to need some antacid tablets, some water, and some ice cubes, and a source of heat. Now, to keep this fair, I've placed the same type of heat bulb on each of these lamps, and I've placed them an equal distance from each of the containers. So it should be a fair trial, but of course science tells us that we should do this over and over again. So what I'm going to do off camera is I'm also going to switch these around to make sure that all of the variables are consistent and that I'm getting the same result. If I'm not, there may be something wrong, or I may be wrong. But let's get started with our demonstration. So I hope that you've gotten a better understanding of what greenhouse gases do to our planet in terms of heat retention. And remember, those greenhouse gases are a direct byproduct of burning fossil fuels, those non-renewable sources of energy. Now, how do we start curbing those negative side effects? Well, we start using alternative sources of energy. And one of my favorite alternative sources of energy, is solar energy. And I've listed some of the benefits here. So it reduces air pollution, right? It makes sense because the less fossil fuels you burn, the less pollution you put out into the air. It reduces water usage. So a lot of people don't think about how much water goes into refining oil, or even in hydroelectric power, you have to divert water in order to create energy. So it would reduce water usage, which is also a resource that we need to be careful with. It improves human health. Well, if you have less pollution in your air, in your water, in your food, your body is going to be healthier. And finally, it helps fight climate change. So we've been getting a lot of extreme weather, and there is a consensus among scientists that it is a direct product of human meddling or human activities, such as the burning of fossil fuels. So I hope that you guys have a healthy discussion about alternative sources of energy in your classroom. And thank you guys for coming to this portion of your virtual field trip. I will see you guys next time.
My name is Mr. Monroe, and we are now getting ready to investigate fossil fuels, or to look at fossil fuels. And I have a short presentation that I'm going to present to you, and then I'm going to come back and show you some examples. But there's a couple of things I want you to consider as I go through my presentation. Just maybe there might be some questions your teacher might ask you later on, and hopefully by the end of this presentation, you'll be able to answer concerning fossil fuels. First of all, I want you to get out of this presentation, I want you to get an understanding about what makes a resource a non-renewable resource, okay? And then I want you to be able to name at least 2 commonly used fossil fuels. So let's get started. As you can see right there listed are coal, oil, and natural gas. These are considered to be fossil fuels. Now, electricity is a benefit from those fossil fuels, so it is considered to be a secondary source of energy because it takes other sources of energy, such as coal or even solar, to create electricity. And now we also have wind generators that create electricity also. Currently, most electricity is generated through non-renewable energy resources. Most electricity in the United States is generated by coal-burning power plants because it is the cheapest to use and produces large amounts of energy. The 3 types of fossil fuels are coal, oil, and natural gas. Fossil fuels are the most commonly used non-renewable resources. Now, students, listen, when we talk about non-renewable, we're talking about resources as they're being used. They don't replenish themselves in a timely manner. It seems like we use more than is actually replenished in a certain amount of time. So it's considered to be non-renewable. The energy in fossil fuels originally came from the sun. The sun provides energy to plants, and the plants use photosynthesis to help them grow. The ultimate source fossil fuels is from the sun. Photosynthetic plants and marine algae lock this energy into organic matter. When we burn plants, coal, oil, or gas, we release the sun's trapped energy. Burning fossil fuels releases their stored energy. 3 problems with burning fossil fuels are air pollution, water pollution, and soil pollution. Carbon dioxide is released when burning fossil fuels. Coal is an organic rock that originally came from dead swamp grass that compacted over millions of years. The fossil fuel, the remains of plants that lived and died around 100 to 400 million years ago, when parts of the earth were covered with huge swampy forests. Coal is considered a non-renewable energy source because it takes millions of years to form. Of the fossil fuels, natural gas produces the least amount of pollution. Natural gas is a natural occurring hydrocarbon gas mixture consisting primarily of methane with other hydrocarbons, carbon dioxide, nitrogen, and hydrogen sulfide. Natural gas is an energy source often used for heating, cooking, and electricity generation. Petroleum oil is a non-renewable fossil fuel, usually found underground in reservoirs located in sandstone or limestone. This fossil fuel is made from sea plants and animals. The energy source used more than any other in the USA is oil. Gasoline is made from the fossil fuel oil. Oil and gas are formed from the remains of marine plants, animals, and microorganisms that lived in seas millions of years ago. And you can see in these images, the diagram, it shows just how they were existing and where they actually were during the time that they were alive. And then it took millions of years for them to be broken down and to form these types of fossil fuels. Propane is a non-renewable fossil fuel also. That is a derivative of natural gas and petroleum. When present supplies of non-renewable resources are used up, there will be no more. It is estimated, proved reserves at the current consumption rate, that in 210 years, there will be no more coal. In 42 years, there won't be any oil. And in 60 years, we won't have any gasoline. So that's pretty scary right there. And I'm going to stop sharing my screen right there. And I have some more information I want to share with you just a little bit. I have some examples of some fossil fuels here. Here is a chunk of bituminous coal. And I can remember using coal, or my family using coal. I'm old enough to remember that that's what they burned in a stove to keep our house warm instead of burning wood, simply because the coal burned much hotter, okay? Now, the state of Texas is rich with some fossil fuels. We have coal deposits that are found in our state. And I'll tell you this, the most important product coming from the ground next to water is petroleum in this state, okay? So there is a lot of oil deposits that are found in this state. And then, of course, we use that petroleum for energy uses, but there are also a lot of petrochemicals that are also used from petroleum. And the state, that's one of the state mainstays, is petroleum. Now, listen, there's an advantage. The abundance, the amount of fossil fuels produces a much larger amount of energy and low-cost transportation. But the disadvantage is pollution. It pollutes the environment. So hopefully I've helped you learn a little bit about non-renewable resources in the form of fossil fuels, and I want you guys to have a good day.
Stewart wanted a definition of renewable resources. Renewable resources include biomass energy, such as ethanol, hydropower, geothermal energy power, wind energy, and solar energy. Biomass refers to organic material from plants or animals. This includes wood, sewage, and ethanol. The ethanol comes from corn. The next time you fill up your car or your dad's car or your mom's car, look on it, it'll on the pump, and it'll say something about this material contains 10% ethanol. And then the new one that they have now contains a whole lot more. Thank you so much again, teachers, and thank you for joining us. And Now we're going to share our screen. During this virtual field trip, students evaluated how the use of energy, water, mineral, and rock resources affects Earth's subsystem. They also differentiated between renewable and non-renewable resources based upon the rate of formation and use. Ms. Ram told you about water resources. Ms. Ramirez discussed mineral and rock resources. And Mr. Dominguez just told you about renewable resources. Thank you so much for joining us. And if you would, teachers, go to www.tiny.cc/hsfeedback, fill out a very short form and send it back to us. We would appreciate it. And now I want you to have a great rest of the day. And more importantly, I want all of you to have a great rest of your life.